Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now in this video we are focusing on P1 paper, that is Pure Math 1 AS level math. This is of May-June 2025 and yes, this is the first variant. So let's get started. Now the first question that we see, it's about a trig equation. Solve the equation. We solve it for the variable given, which in most cases is theta. Sometimes it's x also. So now this equation is given and the range of values of theta is between negative 180 and positive 180. That means if you go in anti-clockwise direction, that is from 0 degrees to 180 degrees. And if you go in clockwise direction like this, that is from 0 degrees to negative 180 degrees, that is clockwise. So basically you are covering all four quadrants. But instead of 0 till 360, it is 0 till 180 anti-clockwise and 0 till negative 180, that is clockwise. So let's look at the working. The first thing is, let sine theta equals to s, and then we have the other thing, that is 6s square is s plus 2. So now over here, this is all basic working, multiplied throughout by s, you get this quadratic equation which is factorizable. So now this is about middle term factorization. So this is middle term factorization. You get two factors. Let me go down a bit, and then you get sine equals to negative half. This one, let me grab a highlighter. So now sine equals to negative half, that's one thing, and the other one is sine equals to 2/3. So now when sine equals to negative, that means we are talking about third and fourth quadrant. When sine is positive, we are talking about first and second quadrant. Now it's the same basic working. That is over here, that when it's about third and fourth, we have to go clockwise. Basic angle is calculated with a positive ratio, that is 30 degrees. And for first and second quadrant, go anti-clockwise. Basic angle is this much. So now over here, let me remove this. Now in this thing, why we are getting negative 30, let me explain this to you. So now let me draw a grid over here. And if we were talking about the normal third quadrant and the normal fourth quadrant, so let me draw a line over here, let me draw a line over here. So now this diagram is not drawn to scale. This is 30 degrees basic angle, and this is coming out to be 210 degrees. And again the basic angle of 30 degrees, and this one is coming out to be 330 degrees. Now 210 degrees anti-clockwise is the same thing as 150 degrees clockwise, which is written as negative 150 degrees. So technically 360 minus 210, that is 150. It's clockwise. Clockwise angles are negative. Similarly, if this is 330, basic angle is 30, go clockwise. So let me write over here, 330 anti-clockwise is the same thing as, which one? That is 30 degrees clockwise, which is the same thing as negative 30 degrees. So that's how these two values are obtained. And then over here, this is the first quadrant, 180 minus basic angle, that's the second quadrant. Take care of the accuracy. If it's inexact, then work in one decimal place for angle in degrees. And make a habit of writing everything down, starting with the smallest, that is negative 150. So that is the smallest. That is negative 30. The next one, 41.8 degrees, 138.2 degrees. These are the final answer for this particular question. Question number 1. Let's move to question number 2. What is this about? The equation of a curve is such and such. The gradient function is given. The curve passes through the point such and such. Find the gradient of the normal to the curve at this point. We know that the gradient of tangent is dy by dx, and we know that gradient of normal is the negative reciprocal of gradient of tangent. So now keep this knowledge in mind. Now, first of all, it's asking find the gradient of normal to the curve. We plug in x is equals to 4 in this equation. We evaluate and we get a different kind of answer. Normally, we don't expect such a big answer. But remember what I always say, expect the unexpected. So expect the unexpected, and that is what you're getting over here, a big answer. That is gradient of tangent, therefore gradient of normal is the negative reciprocal. That is the first thing. The second thing, most likely it's about equation of the curve, and yes, that is the thing. So if we have the gradient function, what do? We integrate it. So now how do we integrate? Let's have a look. We integrate according to chain rule, increase the power by 1. Let me highlight this. So that is increase the power by 1, divide by the new power, divide by the coefficient of x, and of course it's only valid for a linear expression. Yes, it's a linear expression. There is also another limitation, but that's of no use to us. This is just simple integration. Don't forget constant of integration. How do we evaluate it? First of all, simplify. So first we simplify it. Once you simplify it, then we plug in the value, which is x is 4, y is negative 11 over 2. We evaluate it, we simplify, we take care of everything, and we find the value of c, and where it is. That is the value of c, which comes out to be 2. Now this thing over here, that is 4 raised to power of 3 over 2. That you can use a calculator. Also, let me draw a box over here. That is how it's done, which is it can be done in two different ways. 4 raised to power of 3 over 2 can be written as 4 raised to power of 3 raised to power of half, which is 64 raised to power of half, which is 4. 64, the square root of 64 is 8, my bad. And over here, this is 4 raised to power of half raised to power of 3. That is 2 raised to power of 3. That comes out to be 8. So that is indices in full action. And that is how you get the equation of the curve. Rewrite everything, substitute the value of c, which in this case is 2. So pretty basic question. That is question number 2. Question number 3. Now it says the third term of a GP. Now let me highlight it. The third term of a GP is 18 and the sum of the first 3 terms is 26. It is given that the common ratio is negative. That means if you're getting a common ratio which is positive, discard it. First thing, find the 10th term of the progression. Give your answer correct to 3 significant figures. So basically, we first have to find the unknown A, the unknown R, and then work it out. So now, if this is a GP, then the third term is AR square, that is 18. And the sum of the first 3 terms, I'm adding it individually. Otherwise, I'll get a cubic equation. I'll add it individually, that's 26. From here, make A the subject. From here, make A the subject, or you can substitute. So basically, what I'm doing is that, let me just highlight this thing. And over here, let me change it into red color. So now this thing, red over here, that is highlighted and it is substituted over here, it is substituted over here. The rest is algebra. You multiply, you simplify, you get a quadratic again. Quadratic is all over the place. And then again, this is about middle term factorization. So this is middle term factorization. We get 2 values of R. One of the R is positive, the other R is negative. The positive one we discard, the negative one we accept. So now when R has this value, let's evaluate this thing, which is A. So A is 18 divided by R square, and then we get the value of A, that is 32. So R is there, A is there. We are looking for the 10th term, that is A into R power 9. And now at this point, you can start using the calculator. So now use a calculator, simplify, work in 4 significant figures. Final answer, 3SF. Then over here, they are also interested in the exact value. So not only are they interested in decimals and significant figures, they are also interested in exact value. You should be well versed in it. So now sum to infinity is a over 1 minus r, and we simplify, we get this beautiful answer, that is 128 over 7. So 3 questions are done and dusted. Now let's look at this diagram first before we proceed. Now this looks like a traditional question of area under graph or maybe volume. So now first of all, the curve is below x-axis. So remember one thing that will be needed over here, that is area under curve or line below x-axis. It will come out to be negative. So for area, discard negative sign. Yes, it will come out to be negative, but what we have to do is to discard negative sign. That is one thing. The second thing is that this thing over here, that is under a straight line, that is a triangle. So no need of integration, just for, use the area of a triangle formula and then you can find it. So basically the strategy is this: till 1 till 16, this is given. 1 till 16, find the area under the curve, subtract from it the area of the triangle, take care of this thing, and you will get the answer. So now it says the diagram shows the curve with this equation and the line with this equation. The x coordinates of the points of intersection are 1 and 16. So that is 1 and 16. Find the area of the shaded region between the curve and the line for 5 marks. So now the first thing is pretty simple. That is this thing. When x is 1, find the corresponding value of y. When x is 1, I can plug it in over here. I can plug it in over here. Choose the easy option. The y value is negative 15. So the y value over here is negative 15. Now keep in mind, this diagram is not drawn to scale. No one is saying that the x-axis and the y-axis, the scale is the same. Over here, 16 is this long thing. Over here, 15 is this very short thing. So of course, it's not drawn to scale. That is for sure. Now, when we have this, the area of the triangle, just take the absolute value, that is 15. This is also 15. So half into 15 into 15, that's 225 over 2 square units. That's the first thing. The second thing, that is the area under the curve. Area under the curve, integrate this equation between the limits 1 and 16. Now first integrate each term individually. Integrate, simplify. That is much needed. First simplify. Then plug in the upper limit, then plug in the lower limit. So now over here, if I plug in the upper limit, which is 16, that goes over here, that goes over here, and then I'll plug in the lower limit, that is this one, that goes over here, that goes over here. And now you can use a calculator, simplify as you like. And then we have this value, we have this value. Yes, it's coming out to be negative, discard. So the area under the curve is 504. Area under the line is this much. The difference is 391.5 square units exact. You can write square units, you can write unit square, it means the same thing. So question 4 is done and dusted. So now let's look at this question. This is question number 5. Find the first 3 terms and ascending powers of x in the expansion of each of the following. What is this question all about? This is about binomial expansion. Now the first thing that you need to expand is this, which is 2 minus px raised to power of 5, and we are interested in the first 3 terms. So how do we go about this? That's how we go. The first thing, 5c0, a raised to power of 5 and negative px raised to power of 0. So let me write it down over here. So now a plus b raised to power of n, that is nc0, b raised to power of 0, nc1, b raised to power of 1, nc2, b raised to power of 2. And then what is happening to a raised to power of n, a raised to power of n minus 1, a raised to power of n minus 2, and so on. So that is exactly what is happening. This is 5c0, b raised to power of 0, 5c1, b raised to power of 1, 5c2, b raised to power of 2. The difference between 5 and 0 is 5, 5 and 1 is 4, 5 and 2 is 3. The total power, 5 plus 0, 4 plus 1, 3 plus 2 always adds up to n, which is 5 in this case. And then take care of the positive negative sign. This is what you are getting. that is 32 minus 80px plus 80p square x square. These are the three terms. Similarly, over here, 1 minus half x raised to power of 4. This is the other expansion. This expansion is this. That is 1 plus b raised to power of n. That is nc0, b raised to power of 0, nc1, b raised to power of 1, nc2, b raised to power of 2, and so on. And that is how you get it. So over here, let me highlight this. That is 4c0 negative half x raised to power of 0. 4c1, this thing raised to power of 1. 4c2, this thing raised to power of 2. And you are getting three terms over here. So these three terms are there. These three terms are there. And what do? We multiply it selectively. So now this is the first three terms, the answer of first part. This is the answer of the second part. And we are only interested in the coefficient of x square. Now, how do we get x square? We take this 32, we multiply with the x square term. That's one thing. We take this x square term, we multiply it with a constant. And last but not the least, we take the x term, we multiply it with the x term. So this is x with the x, and that is the constant with x square, and this is the x square with the constant. That is how we multiply selectively. Just focus on the coefficient of x square, add it all up, simplify, and equate it to 93 because it says so. So you have to read the question. That is common sense. You have to read it. So simplify, you get this thing, you divide, you factorize, you get two values. Are they asking both the values? Find the possible values. Possible values, p is negative 1/4, p is negative 9/4. Both answers are correct. Let's move to question number 6. Now it says the equation of a curve is such and such, equation of a line is such and such, k is an unknown constant. Let me highlight it over here. K is that unknown constant, and over here p is the unknown constant. Now in the first part, what are they giving us? They are giving us that the value of k is 2. So you have to insert this value. Similarly, the value of p is 11. You have to insert this value. And what are they asking for? They are asking for points of intersection, and they're asking us the coordinates. So now read this thing carefully. Coordinates means x comma y. Points means more than one point. Therefore, there is a line, there is a curve, so there will be 2 points of intersection. Can't be more than that. And the line. So now over here, that is how this first thing is written. Let me grab my red marker. So kxy, that is 2xy. That is this thing, and p is coming out to be 11, so I have plugged in the value of p. Now solve this equation. You know the technique. That is, just take this y and plug it in over here. So now this is your y is equals to, my bad, y is equals to 11x plus 3. That is right over here. You plug it in. Simplify, expand. Again, it's back to the basic. I mean, middle term factorization is everywhere. I think this is the third time that we are seeing it. So now again, middle term factorization, it's everywhere. Quadratics is everywhere. So now we are getting two values of x. X is negative, x is positive, and both values are perfectly good. So now both values, one of the value is x is negative half, the other one is x is 1/5. And then we find the corresponding value by plugging in this equation. Y is equals to this thing. That's right over here. Y is equals to 11x plus 3. You plug it in, you simplify, and then you are getting these values. Expect the unexpected. And these are the coordinates of the points of intersection. So one of the coordinate is this, the other coordinate is this. And that's the coordinates of the points of intersection. So that is x, that is y. This is x, this is y. And since there are two of them, that is one point, that is the other. So that is the points of intersection. Something very basic but requires effort. Therefore, it's for 4 marks. Question 6, the second part. Now it says it is given instead that p is 4. So now they have given us the value of p is 4. Find the set of values of k. So now find the set of values of k. That means it's about an inequality. for which the curve and the line do not intersect. Curve and line do not intersect. That means it's a question about quadratic. It's about b square minus 4ac. The discriminant is less than 0. So now very first thing is that that is the equation of the curve. So that's right over here. That is the equation of the curve. That is this thing. That is the k over here. And then the value of p, that is this one, the purple one, that's the value of p. Now let me just change the color because it's looking too much the same. Let me grab a green color. So now find the set of values of k, and that is the k right over here, that is the k right over here, and then we will work it out. Now what you need to do is that insert this y over here and then expand, and you get a quadratic equation in terms of k. And now once you reach this particular point, that's right over here, we compare coefficient with what? We compare it with ax square plus bx plus c equals to 0. Again quadratic, but this time this is about the discriminant thing. So now what is a? So over here a is 2 minus 4k. What is b? That is negative 3k. What is c? So now c is 2. So we have ABC. And what is the condition that we are applying? B square minus 4ac is less than 0. Line do not intersect the curve. Intersect the curve. So now this thing is done. And then again we are back to the basics. Again middle term factorization. I think that's the 4th time now. So now we have middle term factorization. And once we are done with the middle term factorization, so now this is MTF, middle term factorization. We know that in order to solve a quadratic inequality, the way that I teach is that drawing a sketch based upon the factorized form is a must. Once you draw that sketch, what do? You look at the sketch. It says less than 0. Less than 0 means region below the x-axis. That is this region below the x-axis. When we are talking about this region, what is the range of values of x for which the curve is below the x-axis? It's in between the two. One single region, one single inequality. That is how you write down the answer. So this is question B done. That's for 5 marks. Very simple thing. Very simple thing provided you know your basics. So now we are on question number 7. It says the equation of a curve is this. Part A, a point P is moving along the curve in such a way its y coordinate is decreasing at 5 units per second. So let me write over here dy by dt. That is how y is changing with respect to time. This is 5 units per second. And since it's decreasing, therefore we give it a negative sign. If it's increasing, we give it a positive sign. Now it says find the rate at which the x coordinate is changing. So we are looking for dx by dt question mark when x is equals to 2. So this is a question about rates of change. Technically it's known as related rates of change. Y is changing, x is changing, t is changing. So that is this thing. We have y, we have x, we have t. X is dependent upon t, y is dependent upon x. In other words, y is dependent upon t, and we will use it right now. Next thing, when you have to differentiate, take it up. So now let me look at this working. The very first thing, that is this. Y is equals to 4x squared plus 9x minus 2 minus 8. First write. Once you have written it thoroughly, then differentiate. Once you have differentiate, then simplify. Then plug in x is equals to 2. When we plug in x is equals to 2, we get this thing, which is 55 over 4. And now you connect the dots. That is dy by dt. That is over here, dy by dt. That is equals to dy by dx into dx by dt. And then once you connect these 3 dots and then you plug in the value, what are you looking for? That is dy by dt. My bad, that is dx by dt. So dx by dt is coming out to be negative. This negative sign means there is a decrease. If it was positive, it would have been an increase. Leave the answer in fractions. Fractions are beautiful. Now the next one, Let me pause for a second for azan. So now let's continue. It's the same question, and now we are on the second part. It says find the coordinates of the stationary point of the curve and determine their nature. So now over here, we already have this thing. Y is equals to 4x square minus 9 over x square minus 8. Not only are they asking for the stationary point, they are also asking for the nature. So not only are we interested in dy by dx equals to 0, we are also interested in the second derivative. D square y over dx square. If it's positive, it's a minimum. If it's negative, it's a maximum. So now first thing first, we already have dy by dx. That is the indices version. And then we again differentiate it and we have the second derivative. So now let me focus over here. That is dy by dx, that is this thing over here. And then we have the other version, that is second derivative, that is this thing over here. So now we will take this orange and equal it to 0. So now dy by dx equals to 0, and then we are getting this thing. X equals to 9 over 4 raised to power of 1/4. That means you have to take the square root twice. So therefore, when you take the square root once, that's 3 over 2. It is square root of 3 over 2. Once with a positive sign, once with a negative sign. So therefore, x is this. And then x is negative version of this. And also remember that x square is equals to this. Also remember x square equals to this. You got this idea? So basically what I can do is that let me write an intermediate working. X square is equals to, that is square root of 9 over 4. That is the version. And then once you take the square root again, you get this thing. So if you need x square, that is the square root of this, which is 3 over 2. And if it's positive, we will write it with the positive value. If it's negative, it's also becoming positive. So now that will play a crucial role. So now over here, let me move ahead. When I am interested in finding the y value, so the corresponding y value has what? So that's the original equation. There is an x square, there is an x square. So now be very vigilant over here. So let me grab this blue thing. This is x squared, this is x squared. So the y coordinate is coming out to be the same. So this is x squared, this is x squared, the y coordinate is 8. That means we have the y coordinate, we have the y coordinate, and I think I've already used the blue color. So let me just change the color. And let me go over here, change it, and let me use a purple type of color, or yeah, this purple would be good. So this is x squared, this is x squared over here, this is x squared over here, that is this thing, and this is what I'm plugging in over here. I'm plugging it over here. That is the y coordinate, that's the y coordinate, that's the y coordinate. And then there are two different x coordinates, one with a negative sign and the other coordinate is one with a positive sign. I hope you got this thing all clear over here. Now this was kind of like a lot of working. Not difficult working, but a lot of working. So remember, dy by dx equals to 0. x4 is this thing. X square is the square root. Again take the x square, the square root of x square, that is 9 over 4, 1/4. We have a plus, we have a minus. So two possible x coordinates over here, but one single y coordinate. Now over here, we are also interested in the second derivative. In the second derivative, there is x power 4. Do we have x power 4? That's right over here. That's 9 over 4. When I plug in this value, so I am getting the second derivative to be positive for both, because x square is 3 over 2, x power 4 is 9 over 4. So it's the same thing. That means we are getting the same 2 points and both points are minima. Normally we have this habit of getting a maximum and then a minimum, but over here both points are minima. So we also get the scenario. Question number 8. Now it's about the circle. A circle with this equation, that's the general form, intersects the line at the point P and Q. Find the area of the triangle formed by the tangents to the circle at P and Q and the line x is equals to -2. So now this is the kind of question that differentiates between an A star versus the rest, because you have to look at a lot of things. So A star or A in one category versus the others. Now, first thing first, what do we need to do? We need the center of the circle. Now, how do we get the center of the circle? We have this thing that is over here, the x square term and the x term. So we have the x square, we have the x term. We have the y square, we have the y term. So this is y square, this is y term, and then this is what you're going to get. Let me just highlight it, use one color over here. We have the x square and then we have the x. Now what is happening over here? We are doing the completing square method. First add, then subtract square of half the coefficient of x. First add, then subtract square of half the coefficient of y. Rewrite the first three terms as a perfect square. So when we rewrite the first three terms as a perfect square, so over here when we use this, we are getting this. And then over here, when we rewrite the first three terms as a perfect square, so then we are getting this thing. That's right over here. So let me just use a different color, and that's over here. And now what do we do with the rest? What do we do with this -9? We take it on the other side. What do we do with this -25? We take it on the other side and we get this constant. Now over here, when we compare it with this x minus h whole square, y minus k whole square is r square, we are not interested in the radius at this point. So the center of the circle is this. That is step number 1. So let me write it in black color. So that is step number 1 that we have done. We have found by completing square, so general form to the completed square form. So we have found what? The center of the circle. Now, what are we interested in? We are interested in the tangents, the gradient, and things like that. So now when x is equals to -2, that is this point over here, when x is equals to -2, we find the y coordinate. You don't have to plug in the original equation, you plug in the standard form. So over here, we, hold for a second, we plug it in the completed square format of circle equation. That will make life easier for us. So this is step number 2. And then when we take the square root, don't forget the positive negative sign, and we are getting the 2 points, that is P and Q. Doesn't make a difference which one you label as P, which one you label as Q. And remember, the center of the circle is right there waiting for you. So now what do? 2 steps are done. The third step. So now we have P, we have C. So we have P, we have C. Let me just remove this. So now we find the gradient. So this is step number 3. Find gradient of PC. Find gradient of CQ. So I've used some color, I think green over here. So let me grab this green color over here. So the gradient of PC was evaluated. And then what we do is that we find the gradient of the negative reciprocal, because the diagram is on the next page. If there is the radius, that's the center, that is P. If we find the gradient of this line, then the gradient of the tangent should be the negative reciprocal. Why? Because radius is perpendicular to tangent at the point of contact. That is the property that we use. We have CQ, and then we find the gradient of the tangent at Q. So T stands for tangent. So there is a gradient TP, there is a gradient TQ. A lot of people, they forget to flip this thing. We have the coordinates P -2, 11. We have the coordinates Q -2, 1. That's the equation of TP. That's the equation of TQ. The two tangents meet at R simultaneously. At R, therefore, solve simultaneously. Now here is the version. Here is the diagrammatic version. You draw a circle. No need to draw a grid. Label the center of the circle, that is 3 and -5. One of the coordinate is this thing P, minus 2, minus 11. So let me write over here somewhere. So P is negative 2, negative 11. And the other one is Q, that is negative 2, 1. And this Q is negative 2, comma 1. So now think about it. This is negative 2. The x coordinate are the same. One has a height of 1. One has a height of 11. So therefore, over here, this is P, which is minus 2, minus 11. That's downstairs. Q is minus 2, 1. That's upstairs. We found this gradient did the negative reciprocal. We found this gradient did the negative reciprocal. And that is how the two tangents would meet at a point. And naturally, it is a must that the y coordinate should be the midpoint of these two. It should be exactly in the same line as this. So look at this, minus 2, minus 11, minus 2, 1. When we find the midpoint, I think we found it somewhere over here. There it is. That is negative 5. So negative 11 plus 1 divided by 2, that is negative 5. So y coordinate is this thing. And then we have solved these two equations simultaneously. So the green equation is the one of PR, the tangent at P. So TP, that is this thing. That is TQ. This is TP, this is TQ. It's your choice how to solve it. What I have done is that I have made x plus 2 the subject in both. I have equated these two. Y comes out to be negative 5. X comes out to be minus 46 over 5. Now look over here very closely. This x coordinate is minus 46 over 5. This thing over here, that is the, what you call the height, up till here, my bad. That is from here till here. So the x coordinate of P is minus 2. This is minus 46 over 5. That will be the height. And what about the base? The base will be this thing, the difference between negative 11 and positive 1. That is 12 units. So now let me minimize it. Triangle, base is 12 units. All good. Height is 46 over 5 minus 2. Just take the absolute value. That is 36 over 5. Area is half base into height. That is how you get this answer. So this is like in-depth coordinate geometry. And people think that coordinate geometry is something easy. Definitely it's not. So that is how this thing is done. Question number 9. Now it says the diagram shows a sector ABC of a circle with center A, radius R, the angle is alpha radian. So instead of theta, they have labeled it as alpha. This is R, and alpha is acute. It is given that the area of the triangle is 4 centimeters square. So area of this triangle is 4 centimeters square. Area of the sector is 8 alpha centimeters square. Find the exact area of the shaded region. Now, as far as the exact area is concerned, that means some fractions or some surds, things like that, that will be used over here. Find the area of the triangle, find the area of the sector and subtract. So 8 alpha minus 4 is the answer. All you need is the value of alpha. So now over here, first of all, area of triangle is half into R into sine alpha. Area of sector is half R square alpha. That is 8 alpha. Once you use this, so let me highlight this. So half into R square into alpha is 8 alpha. Alpha cancel. R comes out to be 4 centimeters at the beginning right away. Nothing special. Now when R is equals to 4, you plug that R over here. And then sine alpha is half. So alpha comes out to be pi by 6. So you have the area of a triangle given, area of sector given. First you find the radius, then you find the corresponding value of alpha. Area of shaded region is 8 alpha minus 4. All you have to do is to plug it in, and this is the exact value. Why is this the exact value? This is exact because it's in terms of fraction, it's in terms of pi. We are not simplifying this, approximating this as 1.3333, something like that. We are not plugging in the value of pi, so this is exact because it's fractions, it's in terms of pi. Simple, elegant kind of question. And then it says it is given instead that the length of the chord BC is this much, but the area of the triangle is still same. Find the area of the shaded region, give the answer correct to 3 is if. Now keep in mind, this first paragraph over here, this paragraph right over here, that is applicable for part A, that is applicable for part B. So this is part A, this is part B. Area of triangle is still the same, but now they have given us length of the chord. Find the area of shaded segment. So now what are we supposed to do? First of all, I have used cosine rule over here. So I have used cosine rule. So this is the included angle, which is alpha. This is the side opposite the included angle, that is the chord BC. And then when you apply it, look at the working over here. Look at the working. It's all basic thing. And over here, this is where you use the calculator. So negative 3 over 2 r square is negative 2 r square cos alpha. The negative cancels out. Cos alpha is 3/4. Alpha is this much. Work in 4 significant figures. So that is alpha right over here. Once you have the value of alpha, what are we interested in? Area of shaded segment. So now the area of triangle is still 4 centimeters square. So it's still 4 centimeters square. Therefore, half into r into sine of this value is 4, and r comes out to be this much. Again, work in 4 significant figures. So of course, there is a new value of alpha. Let me highlight this. There is a new value of alpha. There is a new value of r. Now, of course, there is area of sector is half r square alpha, which is new. Don't forget to write the units, which is centimeter square. So that is the area of sector minus 4. 4 is the same as before. And this is the answer that we are getting. Question number 10. Now it says the function f and g are defined by such and such. Fx is this much, gx is this much. First part, describe fully a sequence of transformations which transform the graph of fx, that is this graph, to the graph of gx, that is this graph. You should make clear the order in which the transformations are applied. So now over here, let me pinpoint something to you. That is this thing. That is done in one of the videos over here. So do check out this video, which was done a long time ago, my bad. And the rule about combining 2 horizontal transformations or 2 vertical transformations, something like that, 1 horizontal, 1 vertical, everything is explained in great detail in that particular video. So that is this one. Just focus on this. But you have to watch the whole video to understand it in all totality. So now over here, let me focus on this. So we have root x. Root x is becoming root x plus 2. That is the first transformation. Then it's multiplying with 3. Then this negative 5 is taken care of. So now the first one is, it's a horizontal shift or horizontal translation. Always mention the translation vector. It's written as plus 2, but it has the opposite effect. So that is the translation vector. The second one, it is a stretch parallel to y-axis, and that is the scale factor. And then another translation, this time it's a vertical translation. Translation vector is 0, minus 5. Now I have a habit of writing the translation separately. Whatever is happening in the order it's happening, so that is the way that I write it. The next one, that is pretty basic. On the diagram, show the graph. The graph diagram shows the graph of gx, that is gx. On the diagram, sketch the graph of G inverse together with any relevant mirror line. So y is equals to x, that is the mirror line. And we also know this thing, a point such as AB becomes BA when the reflection is in the line y is equals to x. But now over here, there is anything as such. Let's say if this point was m comma 0, if this point was given, so we would mark this thing as 0 comma m. And since this one is moving away like this, therefore this one is moving away. So if I fold it along this line, this is the concept of line symmetry, which you have done in O levels or IGCSE. That is the basic idea. Next one is also pretty basic. Find an expression for G inverse x. So we always write the statement, the policy statement. Y is equals to gx, therefore G inverse y is equals to x. This is the domain of the original function. It's giving you a range. In the inverse, we plug in the range, we recover back the domain. That is the basic idea. Input, output, swapping. So now y is equals to this thing. So y is equals to gx, and hold for a second. Let me write up till here, show up till here. So now this gx is replaced with y. So this gx is replaced with y. And then you make this x the subject. We make this x the subject. But what is x equals to? X equals to g inverse y. X equals to g inverse y. But we have a habit of writing everything in terms of x. So we write g inverse x is such and such. It's about squaring, nothing to do with the positive or the negative sign of the square root. Yes, if the original was quadratic and then we get a square root, that depends on the direction with comparison to the turning point. If we go to the right of the turning point, the square root has a positive sign and vice versa. Now, what is this part? State the range of G inverse. Very simple. Range of G inverse is the same thing as domain of Gx. That is something very basic. So again, that is this concept of flipping. So now if this is Gx, this is G inverse x, and the domain of Gx becomes the range of this becomes the domain, vice versa. So range of G inverse is domain of Gx. Domain of Gx is given as this. All you have to do is to write the symbol over here. That thing is for only 1 mark, something very basic. The function hx is defined as such and such. So hx is a straight line, and find the value of G inverse h of 4. So first evaluate h of 4, that is 2. So G inverse h of 4 is basically G inverse of 2. So now just plug in this 2 over here, and this is what you are getting, that is 31/9. Again, this is 1 mark thing. So very simple, 2 marks over here. This is 1 mark. That's right over here. This is 1 mark. This is 1 mark. And now we are on most probably the last question. Explain why the composite HG inverse cannot be formed. Now the rule is, in order for a composite to be formed, it is necessary that the output of G inverse should be a subset, should fit in the domain of H. HG inverse X will exist. Now this is again 1 mark. It's a very conceptual kind of thing, but just remember like this. So HG inverse X, what it means is that we go in this order. We have this X, it goes inside G inverse, whatever comes out goes inside H. So the range of G inverse should be lesser than or equal to the domain of H. Do we have the range of G inverse? There it is. We have the range of G inverse. That is this thing over here. And do we have the domain of H? We have the domain of H. Yes, we have it. So x greater than or equal to -2. So let me write it over here. First of all, let me draw a line like this, a number line. And let me mark 0, let me mark -2. So let me mark 0, let me mark -2. The range of G inverse is x is greater than or equal to -2. So this is x is greater than or equal to -2. This purple one is the range of G inverse. Let me write it like this. And the blue one, what is that? That's the domain of H. So domain of H is this thing. This is domain of H. Now this purple line is not fitting inside this thing. If it was starting over here, perfect. If it was starting over here, perfect. But this is bigger, this is smaller. RG inverse is not a subset. It's not fitting inside the domain of H. So therefore, HG inverse does not exist. So they have asked this question after a very, very long time. So now that is how this particular paper, which is May-June 2025, the first variant, which is known as variant 1.1, is all done and dusted. Stay tuned for more content on Mathematics with Shahab Yaqub. Take care, everyone.